All right, welcome back. We're going to continue on with Unit 1 and dive on into Section 2, which we're going to split up into two shorter videos, shorter lectures. And the assignments that we're going to go with these on your pacing guide are a little bit longer, so we won't make the video as long, and there will not be a video form for this first half of the Section 2 video. So Section 2 deals with the way science works. So key ideas, okay, how can I think and act like a scientist? And how do scientists measure things? And how we're going to split up this section is between these two questions. So in this video, we're going to focus solely on how can I think like a scientist and that particular process. So science skills. We talked about this in Section 1. A lot of you do these without even knowing that you're doing it, okay? You can identify a problem. You may not plan an experiment, but you might be thinking of a way to solve that problem. Your observations, your recording observations, you learn from whatever problem you're trying to solve, and correctly reporting data. Are you going to do whatever that is that you learned again or not? Okay, so that's an example of how you do things every day. Learn from your mistakes. It's a great way to use science skills. We could do these in our classroom, outside of our classrooms, in our daily lives. And again, you may not even know that you're doing these. So critical thinking. Okay, critical thinking is extremely important, not only in science, but in your day-to-day life. Critical thinking is the ability and the willingness to access claims critically and to make judgments on the basis of objective and supported reasons. Critical thinking is solving problems by asking questions, making observations, and using logic. Okay, so it's making decisions based on knowledge that you gather and that you interpret and that impact you. That's critical thinking. Okay, it's important for us all to think for ourselves, and that's one thing with this particular class that I really try to emphasize is I'm not so much worried, especially on the front end of this class, about right or wrong answers. What I am worried about is you getting the gears turning in your mind, and you think and you justify what you're thinking, and you explain it, and you relate it, and those are great skills to have that then start leading into being able to produce right answers. All right, so the scientific method. Now you can get on Google or any other search engine and type in the steps of the scientific method, and you may get anywhere from 10 to 15 different steps or ladders or diagrams that may say different words, but they all go back to semi the same thing. Okay, but we're going to look at this particular set here, and as I said, you could find other ones all over the place, especially on the internet. So, first step, observe. You're going to observe anything in nature that might be of interest to you or may make you ask a question, which takes you into step number 2. Formulate or create a question. What do you want to know about whatever it is you just observed? Excuse me. Step 3, research and collect data. Okay, so this is, I always struggle with this as a student, but I'm trying to, over the years, find ways to make it make more sense to my students than it did to me when I was in your seats. This is pre-information, okay? This is not necessarily a research project, so don't think of it as that. I used to always think of it as a research paper or a research portfolio or a trifold or whatever you want to call it, and that's not necessarily what we're talking about here. Now, you can go research and collect some data, see what you can find about whatever it is you observe, but you don't have to present any type of major research work at this point. Okay, this is your chance to pull knowledge that is already out there about whatever observation you made. Okay, you're going to use that knowledge, whether you already had it or you went and got it, or it's a connection or a combination of both, to form your hypothesis. Okay, so a hypothesis is an educated guess. It's a proposed answer to your question based off the research and the data and the knowledge that you have collected from step 3. Okay, so to kind of summarize this slide, you witnessed or you observed a phenomenon in nature. It made you ask a question. You take that question and you collect what research and data and information you can within reason on that question. And using that information that you have learned, you formulate an educated guess as to what you witnessed in step one. Now, moving on to step 5, it's time to test the hypothesis. And here the sub-bullet says this is the bulk of your experiment. It could be a long process. It has to be a long process, and it has to be a painstakingly detail-oriented process. Remember, back to section 1 of unit 1, this has to be repeatable, okay? So whatever it is you're doing to test your hypothesis, Joe Blow from the other side of the world must be able to replicate your methods, okay, your steps, your experiment, however you want to talk about it. It has to be repeatable in the exact same way it is that you're doing it, okay? Number 6, you're going to observe. Again, what are you going to observe? Your experiment. You're going to watch it. You're going to take notes. You're going to jot down every little thing that is happening, whether it's relevant or not at that point in time, maybe yet to be seen. But any information you're witnessing that you can collect visually and also physically needs to be observed and recorded. In step 7, you're going to draw conclusions. So, did the results that you gathered from your experiment support your hypothesis or not? And again, remember back to Unit 1 video. That doesn't, if it didn't, doesn't mean that it's a failure. Okay. A lot of the great advancements in science were discovered by accident or discovered from failures, discovered from things that were thrown away. So don't automatically write it off if it didn't go the way you wanted it to. If anything, you might learn more with that process than you would if you were 100% on the dot the first time you did it. So if it did not support your hypothesis, then how would you modify your hypothesis based on your observation? So then you go back to your hypothesis, which was step 4, and you modify it based off what happened, and then you do 5, 6, and 7 again. And you keep doing it until you feel like that you've covered all your bases with this, and it's ready to go through the scientific community to become peer reviewed, to be replicated, to see if your data and your methods all line up. So variables. Okay, variables is something that students struggle with, especially early on. Wish we were in person to work on this more. But we'll just have to really focus on it virtually, and then when we get back in person, really kind of revisit this idea of variables, especially in science. So to test a hypothesis, scientists will use a controlled experiment. So a controlled experiment, the best way in the first example that pops in my mind of a controlled experiment is you have multiple different test groups for whatever it is you're testing, and one group is your control group. And what that means is that group is unmanipulated, meaning that they get either nothing or they get something that is not going to affect them at all. So if you're doing a drug trial, you might give your control group might get a sugar pill, which is, they're actually getting something, but it's not going to have any of the effect that you're looking for in maybe the other groups. Or if you're growing plants using different types of fertilizer, you're going to grow one plant that gets nothing but water, gets no fertilizer. That's your control group. It has no manipulation at all. Variables can affect the outcome of any experiment. A variable is a factor that changes in an experiment in order to test a hypothesis. Say that again, okay? Remember, we focus a lot on vocab here. A variable is a factor that changes in an experiment in order to test a hypothesis. So there's 2 types of variables, the independent variable and the dependent variable. The independent variable, the best way I can define the independent variable is the variable that you change intentionally. And think about what the meaning of the word intentionally is. You are consciously, physically making the decision to change something about a group. Okay? Whether you're administering it to them, you're giving it to them, you're taking it away from them, or it or whatever, you're intentionally doing it. You're 100% in control of that particular variable. Okay, that's an independent variable. On the other side is the dependent variable. Okay, this is changes in response to the change that happened to the independent variable. So a dependent variable is almost a reaction to whatever it is you did to the independent variable. Okay. For example, you have let's just say my wife wanted to see how long I could sit outside in the driveway in sub-freezing temperatures in gym shorts and a t-shirt. Okay, so she gave me a blanket to start out with. All right, and I'm sitting out there and I'm doing okay. I'm a pretty thick blanket. Well, she comes out and she physically takes my blanket away and takes it inside. Okay, that is her manipulating intentionally a variable. The independent variable is the blanket. She took it away. Okay. Now I could ask you in person, what is going to happen to me now sitting out in the driveway when it's below 32 degrees Fahrenheit and I don't have a blanket and I'm in gym shorts and a t-shirt. And you would say you're going to get cold. Okay. Yes. But my wife did not make me cold. Her removing the blanket is going to make me cold. And I kind of hope that's making sense. Okay, it's just it's a weird example, but it's off the top of my head. She had no control on me getting cold. She has no control on how fast I got cold. But the actions that she took of removing the blanket is going to speed up the process of me getting cold. So the dependent variable in this particular situation is me getting colder faster in response to her removing the independent variable, which was the blanket. Okay? All right. So, independent practice on your pacing guide, you're going to see the experiment practice sheet. Okay, it's going to be two different sheets. One's a PDF that gives you different scenarios, and then the second one is going to be numbers correlating to those scenarios, and you put on there which step of the scientific method this particular scenario is talking about. Okay, so be sure you complete that and you get that submitted. And this will actually be your last assignment for week one of school for us here. Okay. If you have questions, let me know. And as always, I hope you are doing well.